In last week's lesson, we learned how to multiply polynomials, but specifically when we are multiplying a monomial, so one term, by a polynomial. So for example, we did something like this, negative 4x to the third times 2x minus 7. And what we had to do for this problem was distribute the negative 4x to the third to both terms. And then when you multiply these terms together, you have to make sure you add the exponents. So that's why this exponent became a 4, and this exponent, well, that one stayed a 3. Now we're going to learn what happens when there's not just one term in front of the parentheses. There could actually be a bunch of different terms in each set of parentheses. So for this first example, we have two binomials, so we have two two-term factors that we're going to multiply together. Now you will often hear this process called FOIL, and I don't really like to use that term because the term FOIL only applies to this exact example, and that's not the only type of problem we'll do in this section. But if you ever hear another teacher or see this online somewhere being called FOIL, it stands for first, outer, inner, last. And the reason it's called that is because what happens is instead of distributing one term like we did in the problems last week, we actually have to go through and make sure every single term in the first set of parentheses gets distributed to every single term in the second set of parentheses. So for this example, I'm going to start with my first x. I'm not even looking at the negative 2. I'm only looking at the first term in the first set of parentheses. And this becomes a problem just like last week. I'm going to take the x, I'm going to distribute it to x in the second set of parentheses, and I'm going to distribute it to the 8 in the second set of parentheses. We're not worried about the negative 2 yet because it's in the same set of parentheses as that first x, so we're not dealing with it. We're only taking the first x and distributing to the second set of parentheses. So x times x becomes x squared, because again, I'm going to keep my base and add my exponents, and technically they both have a 1 for an exponent. And then x times 8 would be plus 8x. So now I've taken care of that first x. I've distributed the first x. I'm done with it. Now I also have to do the exact same thing again, but now with the negative 2. So it's kind of like we're taking two problems from last week and kind of putting them together into one. So I have to take my negative 2, and because there's like not really a lot of space on the top, you'll see a lot of people write this part on the bottom. I'm going to distribute negative 2 to the x and negative 2 to the positive 8. Making sure that I keep the negative with the 2, not just a positive 2. You can see it kind of makes like this claw shape if you use your imagination. If you're missing one of those parts, then you didn't fully distribute it. So I'm going to do negative 2 times x first. The order doesn't really matter, but we like to keep the same order. Negative 2 times x would be negative 2x. And then negative 2 times 8 would be minus 16. Then we just have one more step from there, and this is a step we should be good at by now. I'm going to combine like terms and simplify. So I have plus 8x and a negative 2x. I'm going to combine those to get x squared plus 6x minus 16. Now let's go over one other example. So we have 3x minus 4 times 2x minus 1. So same thing, I'm going to start with the 3x. I'm going to distribute that to every single thing in the second set of parentheses. This is where if you didn't do last week's assignment, you're going to struggle because you won't know how to multiply those two. So if you don't know how to multiply 3x times 2x, you need to go back to last week's video and watch that first. So 3x times 2x would be 6x squared. 3x times negative 1 would be a minus 3x, making sure I'm careful about my sign. And then I'm going to do the same thing with negative 4. So negative 4 times 2x is minus 8x. And negative 4 times negative 1 is a plus 4. Again, just like almost every section in this class, the biggest mistake people make on these are with sign errors, so just be careful. So then I'm going to combine like terms. The only thing they have in common, or the only two terms that are like terms, are the ones with the x's. This becomes 6x squared minus 11x plus 4. And that is my final answer. So the reason I don't like calling this FOIL, first, outer, inner, last, is because we can actually multiply polynomials with a ton of terms. Like we could multiply 5 terms times 5 terms. It would take forever, and I wouldn't ask you to do a problem that crazy, but I could ask you to multiply a polynomial with 2 terms times a polynomial with 3 terms. So we're going to do the same, it's the same process, it's the same thinking. I'm going to take 4x and distribute it to every single thing in the second set of parentheses. So now I just have to do it 3 times. So I have 4x times x squared is 4x to the third, because I'm adding my exponents. 4x times 3x would be plus 12x squared. Then 4x times negative 9 would be minus 36x. So I'm done with the 4x. I'm going to do the exact same thing with a negative 5. Negative 5 times x squared is minus 5x squared. Negative 5 times positive 3 is minus 15x. And then minus 5 times minus 9 would be plus 45. Now with these longer problems, it's even more important that you're careful about having the right exponents and having all the signs right, because when you go to combine everything, if one little exponent is wrong, your whole answer will be completely thrown off. So now to finish this problem, I'm just going to go through and combine like terms. 4x to the third, that is just by itself. I have 12x squared and negative 5x squared, so I have a plus 7x squared. Negative 36x and minus 15x would be minus 51x. And then I have plus 45 at the end. That would be your final answer.